Yeah, good evening, everyone. So, finally, I'm going to record the second unit, and it is about the fluid flow in food processing. I have given you a brief introduction what I'm going to teach you in this particular unit. So, I'm directly coming on to the business. So, first of all, we'll talk about the liquid transport systems. Yeah, liquid transport system. So, when we talk about the liquid transport system, it consists of four parts. One is the tank, pipeline, pump, and fitting. So, in this unit, we will read or study about uh, what are the different type of material that we used for the construction of pipe and what are the different type of pump. So, before starting that, I'd like to show some graphics that may help you why we need to study about this, what you say, fluid kind of liquid transport system. Here it is, I think. So this is the diagram. I think you may having the book. So in this diagram, the story start with here, that is point number 1, and it's finished at point number 12. So it is a schematic diagrams in which the author has shown the process of pasteurization. So first of all, there is a tank, and from the tank, this liquid is transported through the number of channels, and it is uh, traveled through the heat exchanger, then some kind of clarifier, and finally it's reached to the flow diversion valve. So this is the valve which sends whether to accept this milk or not in case of milk pasteurization. So all the systems, that is the liquid transport system from the tank to this valve, is carried out by the pipeline. Okay, so as I said, it has tank, pipeline, pump, and fitting. So before starting this, I'll like to brief you about the fluid. The term fluid is generally used both for gases as well as liquid. So in case of pipeline, we generally use a particular term conduit. If conduit is round, then we say it is a pipe, and if it is not round, then we say it is a duct. And the main purpose of the pump is to provide the mechanical energy to the liquid when we try to flow the liquid against the this, what do you say, uh, gravity, or you can say this gravity gradient, you can say. And fitting is something that includes your valves, elbows, just to control and divert the flow. So here I have shown some pictures. This is the example of duct, and it is the example of the pipe. Both of duct and pipe grouped under term conduit. And what you say this? If it is round, then we say it is a pipe. So if we talk about the material of construction from which this pipe is made up of, generally stainless steel is used for the construction of these pipes. And why we use stainless steel, everybody knows, because stainless steel is offering a corrosion resistance, and this corrosion resistance is coming from a particular property. That property is known as passivity. Passivity is simply the ability of material to form a layer when it is exposed to the environment or when it is exposed to the air. So it forms a layer, and that layer protects it from the corrosions. So it's all about pipe. Now I'm coming to the pumps. So in any industry, generally there are two type of pumps which are used for the transportation of the liquid. One is the centrifugal pump, and second is the positive displacement pump. I may be running a bit fast. Uh, in case of centrifugal pump, the working principle is that the centrifugal force increase the pressure, and when it rotate inside a casing, I'll show you video, and due to rotation it creates some kind of suction, and later it from the periphery liquid is coming out. So these centrifugal pumps are most efficient with the low viscosity liquids such as milk, fruit juices, where low flow rates are where flow rates are high and pressure requirement are moderate. So before moving further, I'd like to show you how this centrifugal pump works. So here it is the video. If it will work, then you will understand it in better way.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will
So
have a
here it is the
conceptual
casing.
overview of
Inside the
working of
casing there will be
centrifugal
a
pumps.
propeller. They will open it, yes. So this is the disc which rotate inside the casing.
It has got a series of curved vanes fitted inside shroud plates.
So when it
The
start
impeller valve is
rotating,
immersed in water. When the impeller
when
is
it
engaged
start
in rotation,
rotating, it
it makes
create
the
a
valve
low
and
pressure
hoses
here,
also rotate.
or you can say it create a partial vacuum here, and
This
due to
applies
which
centrifugal force to
it
water
suck the
particles,
water.
and the water moves
The water
around
suction
out
takes place from the center of
using the
the
rotational
this
mechanism
rotating
in
blade or
different
this
directions.
rotating disc.
At discharge sides of impeller, both pressure and
And
kinetic
when it
energy
is
of water
rotating, it
will
is
rise.
increasing the potential as well
On the
as
suction
kinetic
side,
energy.
water is
And
getting
this
displaced,
I
so
is
a negative
something where
pressure will
there
be
is a
induced
low
in water.
pressures,
Such low pressure helps the
and due to
suction
low
pressure
pressure there is
penetrate
a
into the
suction.
system
So
again.
pipe the
This
suction of
process
the liquid
continues
is taking place from the center, because due to high speed
This
rotations
is
it
the
has
reason why
created a
priming is
vacuum.
important for centrifugal
And
pumps. If
now
no
this
water is
water has
being
entered
induced,
inside this
then
chamber
negative
and it
pressure
is
induced
rotating
by retained
continuously.
air at
So it
high
is
pressure
expelling the water to
will
the
be too
periphery.
small to suck fresh water inside a casing.
So when it is expelling the water to the periphery, you can see the diameter, or you can say the space between the blade and
It
this
moves
casing
the
is
same direction with
continuously
the
increasing
rotation of impeller.
just to
At
tolerate the
discharge,
pressure inside, and finally the water is discharged from here. So the working principle is
Centrifugal
that
pumps
this
have a
rotating blade is means imparting a
This
centrifugal force,
demonstrates the
and due to
period
centrifugal
and
force
flow
this pressure
duration.
has increased,
Such
and this centrifugal
predictability
force
will help in
pump is
accommodating
able to
newly added water
transport the
flow
liquid.
and will also help in newly added water reduction in flow.
So this is about the centrifugal force. This is furthermore, you can say, detailed explanation, but for you guys I'll say this: it is enough that it is rotating, and due to rotation at a high speed, it is creating a vacuums. From the back side it is attached to a motor basically, and that motor is rotating. As a result, these fans are also rotating and it is creating suction, and finally this water is discharged from the periphery. So now I'm again coming to the slides. So I was talking about centrifugal pump. So in case of centrifugal pump, the centrifugal force to increase the liquid pressure is the basic concept. I think you understand it. Now I'm coming to the next type of the pump. It is the positive displacement pump. So the main difference between the positive displacement pump and the centrifugal pump is that here in positive displacement pump, the application of direct force, we apply the direct force on a confined liquid, and a positive displacement pump produces the pressure required to move the liquid product. So the product movement is related directly to the speed of the moving part within the pump, and it is of two types generally. Either it will be a rotary pump or it will be a reciprocating pump. So thus the rotary pump generally operating concept involve the enclosure of pocket of liquid between the rotating portion of pump and the pump housing. Second type of the positive displacement pump is the reciprocating pump. As suggested by the name, the pumping action is achieved by the action of force by a piston to the liquid within the cylinder. So for this again I'm going to show you a video, and this video will help you how this positive displacement pump works. Yes, this is the positive displacement pump, and I'll mute this guy. See here, this is the tubing, and this device is rotating. It is exerting pressure here, and it is taking the liquid with him. Oh, yeah. So in this way, this pockets means the liquid is traveled in term of pockets, and it is transported. As I said, there are two type of pump: reciprocating and rotary pump. In case of reciprocating pump, there may be further deviations, like it either we can use piston, plunger, or diaphragm. And in case of rotary pumps, we use kind of gear pump or this screw type of pumps. So this is the example of your reciprocating pump. Here it is a cylinder. In the cylinder there is a piston, and this piston is allowed to do backward and forward movement. As it is going up, it allow the suction, and as it coming down, it will release the water. See, as it is coming down, as it is coming down, it will open this valve and it will close this valve. Fine. So the liquid which was sucked during the initial phase, like when the piston start moving up, see, when piston start moving up, this valve has opened. As a result, the water will enter, and now the piston is starting movement. So this valve is closed and it will open. So this is the working principle of the reciprocating pump. So in place of piston, we can use diaphragm, or one more option was there, this plunger. So he has shown it in with, see, you will able to understand what happened. Yes, these are the water molecules. Those have entered. Now these water molecule will move out. So this is the example of a reciprocating pump, and it is a part of positive displacement pump. So I think you understand about the reciprocating pump. So this is a commercial type of the reciprocating pump in which number of cylinders are there. Number of cylinders are adjusted because if we will use a single cylinder, then the water outlet will be a kind of pulsating. It will not be a continuous flow. So to achieve a continuous flow, we use number of cylinders. They are doing the movement in a cyclic manner so that we achieve a continuous and uniform flow. Yeah, this is the pattern by which it is rotating and it is working. So finally discharge, we are obtaining a continuous discharge. So this is piston pump, this is plunger pump. So here is simply plunger is there. We do not using the piston. So this is the commercial example. Yeah, this is the example of your diaphragm pump. So some sort of leathery material is attached. It is, we are doing the same type of the job as we are doing in case of reciprocating piston pump. Once it is coming down, then moving up. When it is moving up, it is sucking the water, and then when it is coming down, it is releasing the water. So this is the example of reciprocating pump, and it is the commercial design which is available in the market. Now we'll talk about this rotary gear pump. So in case of rotary gear pumps, Here it is, this is the pipe, it is attached to the inlet, and in this side is the outlet. So these are the two gears, this water, and this water is, or you can say the liquid is entrapped between the pockets between the two gear, and it is travel between the this rotating gear and the housing. As a result, it is transferred from this side to this side. It will be more visible to you guys. See, the water is, the liquid is coming. Some farmer they are using when they, I think the people, the students, those are from the farmer backgrounds. If they are storing the oil for the peak seasons, so to take out the oil from the big drums, generally there is a pump, same like this, rotary gear pumps. So they used to rotate it with the hand and the liquid come out. So this is another example. This is rotary gear pump. So basically the water is entrapping inside the pockets of the gear and it is conveyed from. So this type of blades are there, so it allows the proper, you can say, a good amount of the water or the liquid to be entrapped, and finally it is discharged. This is a rotary lobe pump. So this rotating devices are making a lobe, and in this lobe the water is, or the liquid is entrapped and it is conveyed. This is rotary vane. So principle is same. There is a direct application of the force on the confined liquid, and liquid is transported from inlet to outlet. So this is the rotating device. Inside there is a rubber tube, and this rubber tube is, you can say, when this blue part is coming in the contact, it is exerting the force. It doesn't allow the liquid to come out, and it take the material inside and with it, and it transport on the outlet side. So commercial design is this one. You can see on the left hand side. What is, so this is the another type of the positive displacement pump. It is known as screw pump. So sometimes we convey the liquid material with the screw conveyor or this screw pump. See how this water is traveling through the screw pumps. These droplets are coming from this side and moving along the movement of this screw. So down there you can see the commercial example. At the top it was a animations. So I hope you understand these two concepts. One is the centrifugal pump and another is the positive displacement pump. So I was here, I think. Yeah. If we categorize the pump, there are the two type of the pump. That one energy is the kinetic type of the pump. You can say it is grouped under the heading centrifugal pump. In case of centrifugal pump, it can be axial flow, mixed flow, radial flow. That is a type or kind of modification of the centrifugal pump. In case of positive displacement pump, there are two main types. One is the rotary type of the pump. Second is the reciprocating type of the pump. In the reciprocating type of the pump, there can be further three divisions or three types. Either it can be diaphragm, plunger, or piston type of the reciprocating pump. In case of rotary pumps, either it will be a single motor or multi motors. So either it will be screw, lobe, gear, or screw type. Sorry, yeah, screw, lobe, and gear. And if it is multiple motor, then it will be piston, vane, flexible. These are the further modifications. But for you guys, it is important to understand what is the difference between the working of centrifugal pump and positive displacement pump, and what are the different type of rotary pump, and what are the different type of reciprocating pump. So I think it's enough for you. Now I'm coming to the next part, that is the property of the liquid. Okay, in case of property of the liquid, before starting the property of the liquids, we have to deal with some property of solid also. So I think I have explained you many times what is the meaning of elastic material, what is the meaning of plastic material, and what is meaning of the fluid materials. So to differentiate this elastic material, plastic material, and fluids, we will consider a kind of particular characteristic, that is the deformation. Deformation means, for example, when we take a bite of biscuit, then we are applying the force with the help of our teeth, and as a result, that biscuit get fractured in our mouth. That is known as deformations. Or you can say, when you pour the water from the top and it is coming down, and then slightly it's start moving on the fluid, that is also the type of deformation. So elastic solids are those solids when we apply the force, there is a deformation, and as we remove the force, it regains the original shape. And there is one another material, that is plastic material. In case of plastic material, the deformation takes place. I'm sorry.